across 90 countries, where 1,150 papers were submitted and 350 were accepted, contributing to the success of this conference, and the papers will be published in 4 volumes this year. We're thankful to all our guests present on this platform who join us digitally for this conference in these unprecedented times. And we hope that this conference will still be fruitful in terms of technical knowledge, and hope that you enjoy this last day to come and our interactive sessions. I'd like to welcome you to technical session number 4, and further introduce you to the chair of our session, Ms. Dr. Tanupuri Chaudhary. Just to give a little bit of background on Dr. Chaudhary, he has received his bachelor's from CSE from West Bengal University of Technology in Kolkata, and a master's from CSE from Dr. MGR University in Chennai. He has also received his PhD in the year of 2016 and has 10 years teaching experience as well as in research. Currently, he is working as an associate professor in deputy of CSC and UPES Dehradun, recently receiving Global Outreach Education Award for Excellence in Best Young Researcher Award in GOECA 2018. His areas of interest include human computing, soft computing, cloud computing, data mining, and many more. And I'm sure that he will thoroughly enjoy your presentations today. And we'll also be limiting questions to our chair. So I'll just explain slightly how today will go, and then I'll let our chair introduce himself and say a little before we start our presentations. So presenters, you'll have 12 minutes to present your papers, followed by 3 minutes for Q&A. If you do start overrunning, I will let you finish your slide, but I do apologize if I do have to interrupt just to try and get things moving along, just to stick on schedule. And I also apologize if I do get any names, pronunciations wrong. I wholeheartedly do apologize for that. But yeah, over to you, Dr. Chaudhary, if you have anything to say before we commence.
Jay, thank you. And I'd like
We're just having some problem. Maybe if you can unmute yourself, sir. Hello.
Am I audible?
Yes, we can hear you now, sir.
Yes, please start the presentations. Thank you.
Not to worry. Thank you, sir. So on to our first presenter. It is Adis Alidzok from Bosnia and Herzegovina, and his paper title is Application of Adjusted Differential Evolution in Optimal Sensor Placement for Interior Coverage. So sir, if you'd like to unmute yourself, you can start to share your screen and start with your presentation once you're ready. Thank you.
Okay, thank you very much. Just a moment. Okay, do you see my presentation?
Yes, we can see and hear you, sir.
Okay, thank you very much. Okay, my name is Adis Alidzok, and I come from Bosnia and Herzegovina, the city Sarajevo, University of Sarajevo, and I am a associate professor at Department of Mathematics and Computer Science. Today, I will talk the application of adjusted differential evolution in optimal sensor placement for interior coverage. First of all, I will give some motivation related to this problem. Suppose that we have two-dimensional projection of 3D space presented as simple convex polygon. The main aim is how to put the smallest number of sensors inside of these polygons in order to achieve the interior coverage. First of all, I will introduce some mathematical definitions related to this problem. Polygon P is a concave if there are 2 points U and W inside of polygon P, such that the UW is not entirely contained in the polygon P. any point Q from P is said to be visible from any other point W from P if the segment QW doesn't intersect the boundary of the P and it's entirely contained in the polygon P. And the second and the third definition for any point Q from P, the visibility region or the fan is the set of all points in the polygon which are visible from a vertex U. Okay, in order to perform interior coverage, first of all, in this paper, we perform the composition of a polygon, and it implies separation of polygon into a set of non-convex components such that the union is the entire region of P. Okay, in order to perform the composition of polygon, in this paper we exploit the triangulation of polygon, and we have implemented a very efficient algorithm whose time complexity is proportional to n log n. The triangulation of the concave polygon P composed of n vertices produces n-2 triangles or components such that the fan Fj contains the indexes of components which are visible from the vertex Vj. In this slide, we can see one example of interior covering of a simple polygon. And for this example of the simple non-convex polygon, only 4 sensors are required to perform interior coverage. The sensors such as V2, V7, V12, and V13 are enough to perform the interior covering of this simple non-convex polygon. Okay. From this example, we can see that from vertex V7, we can cover this triangle, this one triangle, this one triangle, and this one triangle. And because of that, we have that from the vertex V7, fan F7 has indexes 2, 3, 4, and 6. Okay. And the contents of the other fans can be determined quite analogously. For example, for the fan F6, we have these elements 2, 3, 5, and 7, as we can see from this slide. Okay, from the vertex V6, we can cover this triangle, this triangle, this triangle, and this one triangle. Okay, also the polygon P can be covered by the sensors V10, 11, 13, and 19. What does it mean? It does mean that it doesn't exist the unique solution for optimal sensor placement. In this slide, we have an deterministic approach. In order to solve this complex problem, in this paper we have exploited 2 methods. One is a deterministic method, we call it suboptimal sensor location method, and the second one is based on the stochastic optimization. The first one, deterministic approach, composed of 5 steps. In the first steps, we initialize the number of sensors to 0 and initialize the list S to empty list. After that, we perform triangulation of the convex or non-convex polygon to obtain triangles or components. In the second step, for each vertex Vi, we determine the fan Fi by adding indexes or components into Fi fans, which are completely visible from the vertex Vi. Then we initialize the list of all fans as follows. In the third step, we repeat steps 4 and steps while and steps 5 while NS is different from N. In the step 4, we find the fan that has most elements and denotes its index by I. Then we put to the list as the sensor Vi, which was referred to the biggest found in fan Fi. And in the fifth step, for each fan Fj, do the operation as follows. And we update the number of sensors as follows and remove the fan Fi from the list F. Okay, this deterministic approach doesn't generate the smallest number of sensors. Because of that, in this paper, we have exploited stochastic approach based on the differential evolution. Differential evolution is a continuous optimization method. And because of that, we need to perform some modifications. In this paper, we have used adjusted discrete differential evolution. First of all, we design an agent as a vector. where the binary coordinates VIK are related to the indices of fans and this dimension of the problem, or in this case, this number of fans. Okay, in order to speed up the search process of the algorithm, instead of looking at n fans for a polygon composed of n vertices, we will consider all those fans that are obtained after eliminating. What does mean after elimination? Elimination says that if vertex I can see all the components contained in the fan Fj, then fan Fj covers fan, then fan Fi covers fan Fj, and the fan Fj is removed from the set. Okay, after that we need to perform the selection solution. For example, selection solution, for the polygon presented in slide 7, the solution presented as follows with five components is the optimal solution. It does mean that the fans 2, 7, 12, and 13 perform interior covering by using the components contained in them. Because this problem is not unconstrained, and because of the differential evolution is continuous optimization problem developed for unconstrained optimization. In this paper, we used the constrained optimization, and because of that, we need to say what is feasible and infeasible solution. The solution is infeasible if an agent is unable to perform an interior of covering. For example, for the polygon presented in the slide 7, the solution V presented as follows is not feasible because the components F2, F12, and F13 do not address interior covering. Okay. In order to deal with constrained optimization, in this paper we have introduced 3 depth rules. The first one says that n algorithms chooses among 2 feasible solutions the one with the better objective function. The second one says feasible solutions beats infeasible one, and the last depth rule says if both solutions are infeasible, the one with the weakest amount of constraint violation was favored. At the beginning of the algorithm, none type of solution is preferred, while at the end, only feasible solution with minimum number of non-zero elements ones are taken into consideration. Because the differential evolution in the ordinal deals with continuous components, in this paper we need to perform mapping of these components into binary ones. It's done by equation 1. And after that, we need to explain the calculation of fitness function. Okay, in this paper, the fitness function F returns the number of sensors required to perform interior covering. Those solutions which are fittest under depth rules are being moved to the succeeding generations of the algorithms. Okay, in this paper, we have used a randomly generated instances. Exactly, we have used 127 random generated various concave polygons to assess the quality of the results. Each instance is called Rij-K-I, where K denotes the size of the ith instance, and the values of coordinates for vertices of polygon are chosen from the closed interval 0, 500. Okay, in this experiment, in this paper, we exploited 4 algorithms. These algorithms are stochastic optimization algorithms. This is our approach. This is parameters for our algorithms. And in this part, we have seen that that for this algorithm we have used, for example, size population 10 for our approach and number of generations 2000. For particular storm optimization is size population is 100 and number of generations 200, and for stimulating link size population is 1 and number of generations 20,000 evaluation. Okay, for each algorithm we have 20,000 function evaluations, and each algorithm was extruded parallel in 30 independent series. Okay, algorithms in this paper are implemented in the C# programming language. And based on the experimental results, as we can see on the slide, our approach, just the discrete differential evolution algorithm, beats all the other methods such as simulating only particle optimization and deterministic one. Okay, when we in this slide we can see that we have 5 groups of the polygons. For example, the first group has 20 vertices, and the last group has 500 vertices. And as we can see from this slide, for example, for the first, for example, for this instance, we have in the best case, our algorithms consumes only 77 sensors. Okay. The summary results related to the table shown in the previous slide is follows. Our approach, ADDE approach, requires only 713 sensors. Particle swarm optimization needs 884 sensors, and the deterministic approach requires 817 sensors. Based on this, it follows that our approach consumes 104 sensors less than the deterministic method and 171 sensors less than the particle swarm optimization method. In the average case, our approach takes approximately 95 sensors less than the deterministic approach. Okay, in this slide we can see the mean number of sensors and mean time processing provided by proposed algorithms for 127 random generative instances through 30 independent series. As we can see from these bolded values, our approach is superior compared to the simulated linear particle swarm optimization and deterministic method for the polygons, which has 20, 60, 100, 300, and 500 vertices. Okay, conclusion and future work. In this paper, we provided two versions of algorithms, one deterministic and second is stochastic optimization. We have used 127 random generated instances. Based on the obtained results, we can see that our approach produces excellent overall performances. In future work, we will investigate efficient techniques to accelerate the first phase of our method. Also, in the future work, we will apply more metric heuristics as well as other types of polygons, such as orthogonal polygons, one-Koch polygons, and other types. Okay, thank you for your attention. Any question?
Thank you very much for that, Adis. Dr. Chaudhry, do you have any questions?
Sir, can you please come to your comparative survey, please?
Sorry, I'll come back to you.
What question is this for health informatics? Is that question?
Yes, that is for your question, sir. Can you please come to your comparative survey? Comparative survey.
You can share your screen again, sir.
Yeah. This problem is related to sensor placement, camera placement, guard placement, and I think that it can be used for health informatics.
Sorry, sir, I am asking, can you please come to your comparative survey, the survey you have done with the other techniques as well?
Just a moment. Okay. Yes, we compare our method ADDE with simulated annealing, particle swarm optimization, and deterministic one.
But while showing the presentation in the fourth and the fifth column, the comparative survey was blank. May I know what is the cause for it?
For this one, yeah.
Yeah, if you can share your screen again.
Yes, if you could share your screen from the green button again and get back onto your presentation.
Okay. As we can see from
this one.
As we can see, simulated annealing is not able to find feasible solution. Simulated annealing is not able to find feasible solution, and we didn't show results for polygons which has.
Okay. I got it. Rather than putting a dash or like that, you can just write NR or not reported like that.
Yeah.
It will be better, I think.
Yeah. Since simulated annealing is not capable to find feasible solution, we didn't show for polygons which has 300 vertex. We didn't show the results, but we didn't obtain the results. Feasible solution.
Okay. Okay, okay. As a whole, it's a very good presentation, and thank you. Thank you very much. No question from my side. More. Thank you. Good
Thank-
presentation.
Thank you very much, Adis.
Thank you.
What we'll do now is move on to our next presenter, which is Francis Alfse from China. And the paper title is Text Rank Keyword Extraction Method Based on Multi-Featured Fusion. So, hello, sir. Can you hear us?
Yeah, I'm here.
Perfect. If you would like to share your screen, and we can continue with your presentation.
Okay. Okay, can I begin now?
Yes, sir. Feel free.
Okay. Good. Depending on your location. My name is Francis Afezi Kofi, and then I am a master's student of Fujian University of Technology, and then I'm a co-author of this paper. I'm going to present on behalf of the main author of this paper, who is not able to make up for this conference. I'm going to speak on a topic, text rank keyword extraction method based on multi-feature fusion. Now, in a nutshell, this is all that I'm going to talk about today. So, shall we begin? Now, we all are aware that keywords unveil the main purpose of a piece of text or document. And before the popularity of the internet, keywords were mostly obtained through manual labeling. And now these days, we are aware that text data on the internet is increasing day by day. And so the manual way of obtaining keywords is almost impossible nowadays. And then this has led to the term keyword extraction technology. There are many ways of extracting keywords from a piece of text, but the problem is that the efficiency of keyword extraction still needs to be improved. Currently, keyword extraction method is divided into two. We have the supervised methods and the unsupervised methods. Now, the supervised method mostly rely on manual labeling of text data before the modeling or algorithm takes place. And the advantage of this method is that the quality of keyword extraction is higher. And the disadvantage is that it is difficult to be independent of languages and specific research fields. For example, if I build my model or algorithm using English data sets, it becomes difficult for me to use this same algorithm on another language like French or German. Yeah. And then the unsupervised method. This method does not require any labeling of data sets. And then it is also further categorized into three. The first one is the keyword extraction method based on the statistical features. Examples include the TF-IDF, and the YIC and the RIC algorithms. The second is the keyword extraction method based on the topic model, and typical examples are the LDA and the BTM. And the third is the keyword extraction method based on the graph model. And examples are the text rank, the position rank, and the topic rank algorithms. Among these three categories, the graph model, the keyword extraction method based on the graph model has achieved greater results. Now let's have a look at the text rank. Before a text rank algorithm is made, we first have to go through some few processes, and the first one is data pre-processing. We have to transform our data set into a form that will enable us to feed it into our algorithm. Examples include word segmentation, stop word removal, and some other steps. The second is to get word co-occurrence relationship. So when we take our data sets, we can try to group them into threes, fours, fives, depending on whichever way we like. And then through that, we are going to get our co-occurrence relationship. And the third step is the word graph construction. We represent our data set in the form of a graph. And the fourth step is the word weight calculation. Every word in the word graph is given a weight, and this weight determines how important this word can be in becoming a keyword. And then after all these processes are finished, each word, the score of each word in the graph is calculated using this formula here. This formula calculates the, let me say, the significance of each word, how they are able to become keywords for us. And one problem we have with this text rank method is that it gives initial weights to words in the graph. It sets initial weights to 1.
Sorry to interrupt. Sorry to interrupt. Your screen is not visible.
Oh. Okay. Is it visible now, please?
Yeah,
Yes,
it's fine.
Oh, okay. Okay, thank you. One problem we have with a text rank is that it sets initial weight of words as 1, and then it does not pay attention to the features or attributes of the words themselves. So based on this problem, we came up with the MFFTR, that is the multi-feature fusion text rank algorithm. The procedure of coming up with this algorithm is almost the same as a text rank. First, we have the word graph construction, where we represent our data as a word graph, and then each node in the word graph represents a word. And then I want to show something here. Please, are you all able to see the picture here?
we are not able to see it, unfortunately, Francis.
Oh, I'm sorry for that. Okay, so, and then the words in the graph are actually connected. And then this connection between them is the edge weight of these words. The second part is the calculation of the initial node weights. With the text rank algorithm, initial node weights are set to 1, which we believe that is not good enough, because we believe that in the documents, every word has, some words have higher chances of becoming keywords than some other words. So why set initial node weights to 1? So we fused the position weights of words and their frequency, and then came up with a new formula for calculating the initial node weights for words in the graph. And the third step is the calculation of dual core network. The dual core network is, let me say, for example, 2 words in the word graph, and then their adjacent nodes surrounding them in the word graph. And the fourth step is the dual core network nodes contribution. And then depending on that, we redefined the formula for getting the edge weights for words in the graph. And then we also finished with a new or improved text rank formula. I'm so sorry, I'm not able to share this picture with you all. And yeah, after our formula was implemented, we made comparison with these 5 popular algorithms: the TF, IDF, the degree centrality, the closeness centrality, the test rank, and the position rank. The mathematical definition of each of these algorithms is what we see over here now. Now, during the course of the experiment, we evaluated our results based on precision, recall, and then F1 measure. And then these terms are defined mathematically, as you all see here. And then here is our experimental result. Each color in the picture here represents one particular algorithm. We performed the experiment on 2 different data sets. The first one being the Leo GVN data sets, and the second one is the Xiatian data sets. Now, from this picture, the precision of each algorithm began on a higher node or higher scale when the number of keywords to be extracted was actually low. And then when the number of keywords we need were getting, or let me say we're increasing, the precision began to fall down here in this experiment. And the recall is the opposite of the precision. As the number of keywords are low, the recall is also low. And then when the number of keywords keeps rising, values also keeps rising. And then the F1 measure initially shows a rising trend, and then when the number of keywords are increasing, it begins to fall. The results on the GVN dataset is not so different from the results on the Xiatian datasets. And then we can also see that our proposed algorithm, MFFTR, is doing really better than all the other algorithms we compared our algorithm to. So in conclusion, we concluded that the appropriate fusion of different word features into the text rank can effectively improve the efficiency of keyword extraction. However, it is worth mentioning that this kind of improvement is also increases the complexity of the algorithm. Therefore, in future research, in addition to the reasonable integration of lexical features, it is also necessary to pay attention to the balance between the change of algorithm complexity and the keyword extraction effects after the introduction of features. This will be necessary to maximize the keyword extraction effects while sacrificing the complexity of the algorithm to the minimum. Thank you so much for your time.
Thank you very much, Francis. Dr. Chowdhury, do you have any questions, sir?
Yeah, Francis, can you please come to your algorithm?
Oh, okay.
Please directly come to your algorithmic part.
Over here?
Yeah, please.
Okay.
As because the algorithm is not mentioned on the PPT, I think. I think you have missed it to
Yeah,
include.
I'm trying to show you a picture here. If
Yeah.
that is okay.
Please, please.
Okay. Please, can you see?
Unfortunately not.
Oh,
What you could do, sir, is potentially if you, on the chat message, there's maybe a way to send me that file and I can share the screen and then you can talk over it.
okay, okay.
So if you go on the chat section, it says 2. If you just click on my name and there's a file, if you upload the file, then I can quickly maybe show it to the audience and you can go on with your questions, sir.
Okay.
But what we'll do is we'll move on with the presentations and we'll let your question and answer session come back once.
Yeah. Please
Okay,
go ahead.
Thank you.
Thank you
Okay.
very much.
Okay, welcome.
We'll move on to our next presenter now, who is Anaksha Sharaf from India, whose paper title is Quality Assistive Text Data Using CRNN. So, ma'am, if you're here, if you could unmute yourself and we can carry on with your presentation. Thank you.
Okay, thank you. Thank you very much. Whether my slides are visible?
Yes, ma'am, visible. Perfectly visible.
Okay. Thank you so much for accepting my paper in this 6th International Congress on Information and Communication Technology, which is going to be held virtually in London, United Kingdom. And the dates are now today, yesterday and today, that is 25th and 26th of February 2021. And my paper title, which I'm going to present, is quality assessment for text data using CRN. It is a combination of convolution and recurrent neural network, and it is authored by me as well as 2 scholars are there, that is Sarthak Khurana and Thalendra Sahu. So I am presenting it on their behalf also. So in our institute, first we have to give some introduction about our institute when we are going to present anything outside our institute. So basically, I am from National Institute of Technology, Raipur, which is the institute of national importance, and it is located in Raipur city, which is the capital city of Chhattisgarh state. And it is well connected with the tier 1 metropolitan cities like Mumbai, Delhi, Chennai, Visakhapatnam, Bangalore, etc. by regular flights also. The institute is autonomous institute, which is fully funded by MHRD, that is the central government of India. The first session of the institute was commenced from 1st July 1956 with the admission of only 15 students, and the departments, there are only 2 departments at that time, that is mining and metallurgical engineering. And now presently the institute offers all the degrees which is in engineering discipline like BTech, MTech and PhD program. And it has also the MCA as well as the applied geology streams in the institute. And the website of our institute is www.nit.ac.in. And in our institute, we are offering BTech, MTech, and PhD admissions. All are through the BTech admissions will be the students who are coming in NIT Raipur. They have to give the joint entrance examination, that is JEE, which is conducted by JOSA or CSAB, and as per the guidelines framed by the MHRD, Government of India. And we have the MTech admissions, and those students who have qualified the GATE, they are going for MTech counseling, that is CCMT, for all NITs, and it is held centrally for all over the NITs. And the PhD students and the admission of the PhD students are based on the written test as well as the personal interview. So that's all about NIT Raipur, and I will directly come to the outline of presentation. First, I will deal with the introduction section, then proposed methodology, experimental analysis, conclusion, and references. So, as I have already discussed that the topic of the title of this paper is quality assessment of text data using CRN. Here the text data which I have found is as data.
Hello. Hello. Sorry to interrupt. Ma'am, actually your voice is breaking.
Yes, unfortunately the connection is seems to be very weak. It's breaking up quite a lot. Unfortunately, ma'am, I think potentially the connection may have dropped. What we'll do is we'll give.
Can we start for the next presentation then?
Yeah.
When ma'am will join, then we can
restart.
connect again.
Our next presenter is Dokshin Lim from Korea, and her paper title is Quick and Dirty Prototyping and Testing for UX Design of Future Robo-Taxi. Sounds incredibly interesting. So Ms. Lim, if you are here, if you would like to unmute yourself.
Hey, so can you hear me?
Yes, we can see you and we can hear you as well. Thank you.
Okay. Hi, I'm going to present my paper, Quick and Dirty Prototyping and Testing for UX Design of Future Robotaxi. My name is Dokshin Lim. I'm an assistant professor at Hongik University, which is located in South Korea. Minnie Lee is my co-author. She's CX designer at Samsung Electronics. I present in this order. First, let me explain the background and our methods. A robotaxi is an autonomous vehicle of level 4 or 5, operated for ride-sharing services as like Waymo. One of major challenges to designers as like me is that AVs are currently not available to everyone. Moreover, evaluating interfaces using a fully functional physical prototype in real-world traffic conditions requires vast amount of resources. So that's why we are interested in quick and dirty prototyping methods. Quick and dirty usability tests require less efforts while still yielding useful results. So these approaches are quite revealing in the early stages of a project as a quick sense check. The main idea of quick and dirty prototyping is to start with cheap and fast prototypes as like ours. It can be achieved by using very low cost, readily available materials on the spot, and it is important to make sure that this type of low fidelity prototype has just the level of detail required and never too much. And another method that I would like to talk about today is when the co-creation method. When the problem is complicated, designers experience limitations in solving problems, and we inevitably accept cooperation with others, for example, engaging end users and field experts. This workshop makes up for the weaknesses of quick and dirty prototyping. The whole process is shown in figure 1 in my paper. And next, let's talk about our hypothesis. This is the user journey of future robotaxi described by Tim et al. Last year. The first iteration takes place at this point, rider-robotaxi match situation. The rider-driver match is very perplexing experience even today between human to human. But how machine to human experience can be simple and easy in the future. The second iteration studies in-car user experiences. In the era of autonomous vehicles, we expect to be able to perform various tasks during the journey. So how future robotaxis could offer in-car environment optimized for the tasks that users would do in future robotaxi. This is our experimental setting of the rider robotaxi match situation. The test subject is a passenger who is waiting for a robotaxi. The windshield, you can see here, of a robotaxi, and the passenger's mobile screens are prototyped as shown in this figure, and the two interfaces show consistent information. The experiment assumed that a situation in which a prospective passenger was waiting for a robotaxi on the road. A passenger calls a robotaxi via a mobile phone, and a robotaxi approaches from the distance to closure. The passenger compares the interfaces on both devices and identifies the taxi. Our hypothesis is that people will prefer minimum amount of information on an abstract level. And to test this hypothesis, three criteria are considered: text information versus graphical information, and user data versus random generated data. And user data can be divided into unprocessed data and processed data. The second hypothesis that we had was that people will prefer automatically set environment. The determinant of this experiment is whether or not the in-car UI is provided based on contextual awareness. So let me summarize the results of our tests. In the first test, our hypothesis was that people will prefer minimum of information in this site on an abstract level. The result of the first test with 9 subjects indicated that all of them preferred random generated data, among which the color option was the favorite one. The option number 1 and 2 were repulsed due to the exposure of personal information. However, this is not quantitative research, it's more qualitative. So digging into why, we understood that even though they prefer abstract information when the car approaches from the distance, many wanted to confirm with specific information right before getting in the car. So as a result, 6 out of 9 subjects suggested a combined approach, meaning from the distance displaying abstract information as like color, but when the car is very close, even using the user ID is okay for them. This is the second test. Our hypothesis was that people will prefer this type of automatic custom UI. But the result is that 3 subjects preferred the contextual UI, but half of them, 3, did not. The negative opinion about this customization feature revealed that they just wanted to sleep or rest. So the customizing environment doesn't matter to them. Also, they mentioned that the travel time was not long enough to consider environmental configuration. 3 people who preferred this feature predicted that it would be useful only if the templates were diversified and refined. So the basic scenario is confirmed based on the results of the 2 tests that we did with low fidelity prototypes. Using these scenarios, to start with this basic scenario, we invited 2 field experts and organized a co-creation session. The main question is that how might we avoid errors in getting in the right car while not exposing personal information or being stressed? So random code should be simplified to 2 to 3 digits. That it was longer in our low fidelity prototypes, and emojis could be very effective and emotional to reduce users' stress. And users have anxiety about the new technology, and so it would be helpful to use emojis rather than random numbers or letters. And even breaking down the scenario into detail level, we might use personal information when the user is very close to the opening door. Another issue that came up from the co-creation session is the customization issue. It is useful, but preferences vary depending on individuals and their context. So it should be activated only when the passengers want. So rather than automatically set the environment, give the option for the user to choose and activate only when users want. In that case, the voice interaction could be very natural interface. Also, the emotion of people is very complicated and complex. Moreover, depending on the same emotion, what passenger wants may be very different. So rather than depending on people's emotion, depending on the journey, experts suggested that defining UI based on other objective factors like the time for the journey can minimize the dissatisfaction from this feature. Another important theme is human technology teamwork. Edge cases occur always and need stronger attention in design, such as in this case, the robotaxi has almost arrived, but only found that this way is blocked when arrived. Then the robotaxi, to create the communication effectively, may call using the AI voice, and then ask for the passenger to move to the location of the car. Then the passenger could identify the location of the car in real time on mobile and move to the location. Okay, we are almost the end. So adding this kind of co-creation session found many insights, and the result of the co-creation workshop was added on more detailed scenario. So enjoy reading the full paper to read this scenario, full scenario. And the conclusion is that when the technology matures, people will choose which robot taxi they will call based on the convenience. Rather, rider car match and in-car environment optimization are the key critical moments in the holistic user journey. Therefore, car manufacturers are continuing developing this type of UI. Okay, I continue my research on UX of future robot taxis and autonomous vehicles, and I look forward to any international collaborative projects with you. And thank you for listening to my presentation.
Thank you very much. Dr. Chowdhury, do you have any questions?
Yes, Dr. Sin, can you please come to the cost of the prototype? What is the basic cost behind it?
Prototype?
Yeah, I'm asking about the cost only, cost.
Cost.
Yeah.
Our aim was to not to spend any money. So we found all the material around us, just the Luno, this small car was available to us already. And we read the book $1 Prototype as a reference while doing this project.
Okay, while designing the prototype or user diagram or datagram or like that, what is the basic algorithm you have followed? Or what is the basic research paper you have followed?
You mean the literature reference that I
Yeah. The references are not mentioned actually. That's why.
I cited on the bottom of the papers.
Okay.
It's like this. The user journey. This is the International Journal of HCI, and also the methodologies. I cited the proper reference.
Okay. Fine. Thank you.
Thank you.
Thank you very much.
Very nice design, actually. Thank you.
Yeah, it looks very, very interesting. I wish I could drive it, to be honest. Have a little test drive. But we'll move on swiftly to our next presenter. Thank you very much, Dong-Sin Kim. And we will move on to our next presenter. I hope you can see my screen. Who is Jorge Dozono from Malaysia. whose paper title is The Impact of Cloud Computing and Artificial Intelligence in Digital Architecture. So Mr. Zuzono, if you are here, if you could unmute yourself.
Yes, am I audible, sir?
Yes, sir, we can hear you.
Yeah, thank you so much. So let me share my screen first. Hold on. Sorry, hold on, wait a sec. Hold on.
There is an option in the share screen option.
Yes, sir.
You just click the share screen option.
Yeah, actually, I bought a new laptop. I just allowed the system configuration. So yeah, I just got it. Sorry. Yes, almost there, sir.
Perfect. We can see you and hear you and see your presentation.
Thank you so much, sir. Yep. So yeah, let me start my presentation. Thank you so much for coming to the paper presentation. My name is Kohei Dozono from Teras University, Malaysia. And I am going to present our paper, which is the impact of cloud computing and artificial intelligence in digital agriculture. So first, agriculture plays a significant economic role in Asia and even in Malaysia. But many crops have suffered plant disease and nutrient deficiencies, and it causes huge yield loss. And however, agriculture is far from being modernized, especially in the rural area. So let's say in Malaysia, farmers have relied on their visual inspection since the domain experts has not been available all places in Malaysia. Therefore, they could not get appropriate treatment for those incidents quickly. Of course, there are some existing studies of digital agriculture system, but those systems have not taken into consideration the real environment, rather than the experimental environment. So let me share this point later on the literature review. Therefore, this study aims to provide a digital agriculture platform to minimize yield loss using AI and cloud computing for a practical scenario. Here I say yield loss is caused by plant disease and the nutrient deficiencies. So like I told you, in research about digital agriculture system, there are many types of systems that have been proposed. For example, water irrigation system, rule-based agriculture system, agriculture management, platform in terms of recursion for greenhouse, agroview application, and the disease-focused application. So including the existing system I just showed, the agriculture system has used cloud computing, the AI. However, not so many systems utilize the cooperation of cloud computing and the AI, and those were not considered use cases in the real environment. So that we designed and developed the digital agriculture system for plant disease diagnosis and the nutrition deficiencies, applying the cooperation of both cloud computing and the AI. So next, I'm going to explain how beneficial it is using cloud computing and AI for a digital agriculture system. Okay, first, in terms of the benefits of using cloud computing in digital agriculture system, it enables us to quickly scale up data storage and the control management easily. Also, this benefit is able to bring a boom for storing vast amount of and various types of data on the platform. The next, cloud technology can benefit efficient and robust platform management with external devices. For example, IoT devices, edge devices, remote sensing devices, and the mobile devices. The cloud can act as the core of the application and smooth those devices management. For example, IoT devices acquire the environment data, then transmit it to the cloud without complicated configuration. Edge devices connected to the cloud will be executed by the cloud operations. Remote sensing devices, such as drone, can collect geospatial data, then send it to the cloud to process it. Lastly, cloud computing is capable of handling complex tasks. For example, big data analysis using various data types with enormous data. The cloud-based platform can be configured with computational resource to suit the application needs, so that this makes a positive contribution for cost. Also, the cloud platform with the mobile apps is able to utilize APIs control for functions so that the mobile device's performance does not need to be worried about since all computational tasks can proceed in the cloud. Okay, then the next, in terms of the benefit of using AI, first, applying AI technology will be able to deal with complex decision-making tasks as parametric estimation. For example, image recognition using deep learning has been applied for computer vision-based disease diagnosis. That improved the accuracy compared to using the conventional machine learning algorithms, which means complicated tasks that could not be handled in the past can be accomplished by using the latest AI technology such as deep learning. Second, more accurate decision-making or prediction could be provided by applied AI technology than conventional method. Generally, the intelligent system's performance depends on the data volume, and the AI comes into its own when there are many data. As the previous section described, cloud technology enables us to handle massive volumes of data. So intelligent systems using AI technology have the potential to outperform traditional systems. Third, AI-based systems and applications could help reduce labor costs and increase productivity. Labor shortage has always been the problem in agriculture industry. At this point, AI cannot replace all human operations, but it can help or be a part of those operations. For example, yield management with AI technology could contribute to farmers' productivity so as to let them know what action they should take to maximize their yield. So through this analysis, we say that AI supports the intelligent part, such as the human brain, and then the cloud acts as the core part of application for smooth and expansible system management. So this is the overview of our proposed system, which has utilized those benefits mentioned just now. So let me decompose each component one by one. So in terms of data acquisition, many different data types will be transmitted, such as images, sensor data, weather data, hyperspectral data, and so on. So our developed mobile app also has a function where users send images to diagnose them to our server. Simultaneously, metadata such as location, specific site, plant entity, and crop type will come with uploaded images. And then the weather API has been implemented into the mobile application to collect meteorological data according to the user's location. So our system also involves agriculture scientists who can collect the data in the actual experimental field and then push them to our storage. IoT devices are to collect field environmental data, and the remote sensing devices will obtain geological details and send them to our data warehouse as well. And then the next data warehouse consists of two types of storage, which are the bucket and the table. And the bucket is called a storage container, and then it can hold one or more records. In our proposed framework, the bucket is used for storing acquired images and the remote sensing data. And in addition, for non-image data management, the NoSQL database has been employed, and all of the non-image data will be stored in those tables. And then in terms of the data annotation, is to collect labeling precisely and accurately in our framework. So in order to develop the model, the label dataset must be necessary, and the data labeling is need to be done by plant disease experts. Our system can facilitate annotation tasks and synchronize with the bucket that contain uploaded images smoothly. And the model development and the deployment are to improve an efficient environment to develop models for plant disease and nutrition deficiencies. Also, this enables us to deploy developed model as APIs. First, annotated dataset is retrieved from the buckets. Then the dataset will be fed into the training script. Those trained models output and the trained weight parameters will be saved into the specific buckets. Finally, the trained model with saved weight parameters is pulled from the bucket to deploy into API to publish models. So yeah, in our current work, we implemented the plant disease diagnosis function. And here I'm going to show the model development and we focused on chili leaf disease this time, especially in Malaysia. Models classified the 4 diseases: bacterial leaf spot, carcospora leaf spot, mosaic disease, powdery mildew, and then the 1 category for healthy images. A total of 1,652 images was split into 80% for training and 20% for testing. This development involved 5 networks and they compared performance between them. And then this is the result of this model development. Each network is evaluated on mean column-wise ROC, AOC. So in other words, the score is the average of individual AUC of each predicted column. So column indicate disease name this time. Then test AUC score has been used to measure the model performance. According to the result, DenseNet 1-to-1 achieved the highest performance as 0.94 to 1, so that this model has been chosen for plant disease diagnosis function as API. Next, this diagnosis result and the recommended measure will appear to the user based on the disease detection result, the diagnosis result, sorry. A diagnosis result show a possible disease, and the recommended measure indicate how to treat each disease. So diagnostic API derives each likelihood for each disease and then provide a disease name based on the highest likelihood. The mobile app provides a diagnostic result to users through the interface, and they can use it in the real time. So yeah, in closing, applying cloud computing and artificial intelligence has the potential of increasing the efficiency and the productivity of digital agriculture system. So our proposed end-to-end system utilized both of their technologies to achieve significant outcome of real-time disease detection and providing the recommended measures. So for future studies, due to the pandemic, comparably, we are not able to collect many data. So we will further improve the diagnosis model accuracy involving various data and carry out disease identification for other identified crops. And in addition, we designed the nutrient deficiency recognition so that we will implement it to the system as I did for disease diagnosis. And further, we will develop and implement the disease prediction function in next studies. So this is a reference which I just refer on this slide. So thank you so much. If you have any question, please feel free to ask me. Yeah, thank you so much.
Thank you very much, Mr. Dazone. Dr. Chowdhury, do you have any questions?
Yeah, presentation is very good.
Thank you so much.
Yeah, presentation is very good. Actually, I want to know that already you have done the disease detection and all part. It's very fine. But how these information will come to cloud? I just want to know this thing only.
In terms of the cloud, so first, due to the pandemic, we could not collect the IoT data from the actual field because Malaysia had the lockdown since the last March. Yeah, so that
it's locked down. Can you please come to your first slide, the name of the paper?
Yes, sir. This one, sir.
Okay, the name of the paper is the impact of cloud computing and AI in digital agriculture. It's fine. AI has been using the ImageNet and all in the digital agriculture also. It has been circulated also. But how the cloud computing is means associated with it?
Yes, sir.
The presentation is definitely shows all the points for the disease detection and your purpose. Everything has been solved and clearly mentioned. But the cloud, how the cloud and AI, these portions are means aggregated. These portions are not clear to me. That's why.
Yes, sir. Thank you so much, sir. So this is in terms of this. So the cloud computing, we applied to develop this workflow in terms to provide disease diagnosis and the nutrient deficiency model. So in terms of this, so if we collaborate cloud computing with the AI, so we can publish or we can develop models smoothly. So let's say on the data annotation, we just use the cloud computing in order to provide annotation tasks to plant disease expert without any configuration. what is the model development, we need a GPU. So we just create the infrastructure in order to let data scientists to develop the model. And then for the model deployment, we need to publish the model as API. So we use just cloud computing technology as the centralized application management. Then we can manage APIs and the model control, model version easily. Then also we can store the tons of the huge heterogeneous data into the cloud. Then we can manage all of the data in the one place. So that's the what I did for the collaboration of cloud computing and the AI technology, sir.
No, okay, it's fine. Thank you.
Thank
No
you so much,
question
sir.
more. Thank you.
Thank you very much, Mr. Zono. We'll move on now to our next presenter, who is Mr. Sakamoto Tanaka from Japan, whose paper title is Bent QR Code Image Rectification Methods Based on Image-to-Image Translation Networks. So say if you can hear us, if you could unmute yourself, and you can start to show your screen and proceed with your presentation. If Mr. Tanaka is not here, if any of his co-authors, okay, no, that's fine. So if you would like to unmute yourself.
Actually, I think from Sar's side, there might be some network issues.
Potentially. Hello, sir, can you hear us?
Otherwise, we can have the video play also.
I believe potentially Mr. Takana may be having some technical issues. So, sir.
No problem. We'll go ahead with the next presentation. Then after, we'll allow him.
Not to worry. I do apologize. What we'll do is hopefully you can rectify your technical issues and we can come back to you. Unfortunately, we'll move on and to our next presenter, who is Mr. Walid Hassanin from Egypt, and the paper title is Designing an Intelligent Agents for eBook Store System Web-Based Systems. So sir, if you can hear us, if you could unmute yourself, just say hello to everybody, and then we can start with your presentation.
Mr. Walid is here.
It appears maybe, oh yes.
Mute. I cannot talk. Can you hear me?
I apologize, sir,
yes, I can hear you.
Because of the voice crisis,
Oh.
we are not allow participants to unmute themselves. So I have to do that.
Okay. Thank you.
Sorry
Thank
for
you.
that,
Thank
sir.
you for presenting me. It's okay. Thank you for presenting me. I'll share screen now. Sorry, give me a minute. Can you see my presentation?
Sorry, I was just muted
Yes,
as well. Yes, we can hear everything and see everything. Perfect.
Go ahead. Okay. Thank you for presenting me. Thank you for accepting my paper. I am Walid Hassanin, assistant lecturer in MTI University in Egypt, Artificial Intelligence Department. My paper, I will talk about designing an intelligent agent for ebook store system, web-based system. My supervised Prof. Dr. Mustafa Mahmoud Arif, Dr. Basant El-Bagouri. They are in Ain Shams University in Cairo, Department Computer Science. Okay, this is my agenda for my presentation. Okay, the new business now, they has become more dynamically in changing requirements, because the reason that the customers always added new requirements and new complex requirements to be developed, that lead to that the internet has become more wide and more connected. Also, this lead to that we have added an artificial intelligence in this part, that to work as a service online, like for example, the cloud computing, Amazon services. And also this services can work as an, for example, case-based reasoning, also agent-based solutions, as an work as an automated software replaced by the human, and also in which to help solve the problems of the customer requirements. In this part, which is a software agents that put it on the cloud as an agent-based solutions, they come with the idea that using the concept of the multi-agent systems, that that the software agents works together in order to solve a problem or a case that helps that the customers problems. And also they had many features, and the most important features is the communication, that they communicate each other. Also, the communication is look like the concept of the sending an email. They're using the concept called FIBA, which is the foundation of the physical the foundation of the intelligent physical agent. So this the FIBA is like the concept of sending email between each other, and these mails can be received by another agent, and they read this mail, analyze this mail, and start executing its request and reply in the same email to another agent. Okay, in the related work, there are many related works. They concentrate on the communication between agents on different systems. The most common that how the message is sent, how the message is analyzed, and how the message is to execute, and these agents executing these message request and reply in the same message. Most of the papers works on how they make the software agent is automatically works and they interact each other, and concentration on how they learn and adapt the environment within it. The most part in the related work that some papers used to add a case-based reasoning, the CPR systems in the agents, but till now we didn't found any papers that the software agents has the CPR reasoning. Thus, the most common that the only papers talking about agent and what is the features, like for example, learning, communications, adaptations, because these features are hard to implement. They takes a lot of effort and time to implement. Even the communication feature is also hard to build. So in case these agents taking too many cost, too many time to handle, but they develop only for a specific case, specific problem about customers' requirements. In my model, I have proposed a model, designed a model that is concentration on the bookstore system, e-bookstore system, electronic, intelligent, that has the communication features, and within a case-based reasoning CPR, in which that the client or that the customer had to request for book, try to finding some book on the system. The software agent tried to search on the book, it found nothing. So it represents a suitable solution for it, not saying that no book found. No, it find that the most results for this book, some people viewed another books related with this book. So the proposed model has components, data model, which is what is the data that he is using, the capability module, is it the functionality, the functions that being implemented, what the communication module, which is the messages that be sent between the agents, and what is the message, which is what type of the message is sent, how it looks like, what is the parameters that it has, and also the CPR reasoning, the engine that be used for providing a suitable solution for every problem. And this is the architecture of the model, that we have two agents, sender agent and the receiver agent. This sender agent is a general, could be any type of agent. For example, for my case, could be, for example, a buyer agent, could be a stock agent, could be any type of the agent. This is only a general picture. The receiver agent also could be the same as the sender agent, which want to communicate. Each agent has its own data module, capability module, has its communication module, and how they communicate each other. They send, the sender send request and the receiver reply in using the communication module, and each agent store its conversation and its results. I added the CPR engine within the receiver agent, which is takes the problem from the sender agent, sending the message to the engine, and find if there a suitable solution for this message. If there a result found, it replies to the sender that the result found. But if there's no results found, it find in its database, find the related problems or the suitable solutions for it. And also it stores these problems in the database in order for learning these problems, either it's a new case or an old case. For example, we have a case study that the customer wants search on the book. So the customer talks to the search agent that he talks to the customer agent that want to find a specific book. He write the title of the book, and the customer agent send this message to the search agent. So I want to show you here that how the message is look like, or the contents of the message. The message, there are something called performative, which is query if you want something asking for a book. Sender, who is the sending, the receiver, who will receive this message. The content, which is the functionality to be used to execute this message. The description describing what is the message talks about. And if there are any parameters that be sent, for example, book title, which is the name of the book. Also, the receiver agent, which is the search agent, starts to this message and receive this message and executing, analyze this message, what it talks about. So the contents is the same, but in addition to a result. The result, which is the list of the books, either if it's found, or the suitable list of the books results found, and the reply back to the customer agent. This message is executing in the including the CPR engine. So the search, the customer agent display the results to the customer on the screen, either it's a browser or a desktop app, any type of the application. And then the customer starts to select this book if it's displayed for him. Okay, so also I have made a system evaluation to evaluate this software agents that I have, but I have evaluated from 4 points of the evaluating these agents that I have. First, we have the learning, and it has 3 factors, which is attribute hiding factors, with what are the attributes in the class, how many attributes, which is only this class use it, no other classes use it, variable density, which total size of the variables it has, knowledge usage, which means the variables, how many used in the if statements, adaptation, which is changing its in case based on the environment, and also it has 2 factors, which is weighted method per class, it count number of methods that built in inside it, and how many exceptional handling factor, how many exceptional handling that if any case happened for the customer entered invalid input, that the system can handle this case and not crash. Also, the goal orientation, that the software agent, what is the role that used to assign to it. This role, for example, is like a kind of the job. Okay, for example, I have the search agent, so its role that responsible for finding the books and displaying the suitable results. So it measured this role. This role could be, the software agent could have many roles and calculate on each role the quality of it. The number 4, which is the social ability, is calculating the message size and how many message types that to perform. For example, it could ask for information, update information, any type of messages. So in the implementation, we have implemented and used data sets, the results, which is the search performance, and finally the evaluation. Data set, we have used the Amazon data sets. They used the 2018 years, the size, which is 2.36 gigabyte on the hard disk. And the feature that we use, which is the title of the book. It has many features, but we didn't use all the features, but the suitable feature for the client, which is searching on a book and then starts to apply filters on these results. So I want to show here the search performance, that how it search takes in finding books. So I started with the 20,000 number of books and given 11 microseconds. So 11 microseconds based on the overhead, there was starting initial finding the books overhead, which is 4. So I have started increase the number of the books, 40,000, and given time microseconds, 60,000, 80,000, 100,000. I found that starting above the 40,000, the time has been decreased. So this is the graph showing that the time starting from the 20,000 till the 40,000, and more than the 40,000, the graph, the line has down a little bit until the 100,000. This is because that the database server that I was working on, which is a SQL server, started storing these results in a cache. So rather than start find from the top, no, it's used the previous results, so it takes time less. And then I evaluated these agents I have implemented In the ebook store, I have implemented 7 agents. And each agent has responsible of his job, has its own role. For example, I have the purchase agent is responsible for helping the customer to buying the products, either to adding its cart, calculating the amount, and so on. So I have evaluated each agent and calculated each factor based on the system evaluation and explained previously, and showed that found that which is giving the values 1 is the best value that shows the software agent is as a product is very good, but shows that which is 50%, 80%, 90%, it shows that is this a good product or not. For example, we have purchase agent that found AHF 56%, but in variable average density shows that the 95%, which is it uses its all variables. So I have calculated, and overall the average that the system covered 81%, which lead that this graph shows that.
But I do have to ask if you could try to conclude in the next minute or so. I do apologize.
Conclusion?
Thank you.
Yes, I almost finished. Yes, okay. The evaluation, the conclusion, calculated in each agent, also the same, calculated the average, and finally showing that the performance of the intelligence agents, how it looks like on each case, on each types of the evaluation, and finally showing that the proposed model is suitable for implementing an ebook store system, and also it can work on any type of the e-commerce systems, including using the CPR systems and using the FIPA, and showing that the system has covered 81% as a performance. And this is the references that I have used. Thanks. Any questions? Thanks very much for listening.
Mr. Hassanin. Dr. Chaudhry, if you had any questions?
No questions from my side. Thank you.
Not to worry. Thank you very much.
Thank you.
We'll move on now quickly to our next presenter, who is again Dr. Akanksha Sharaf from India. Hopefully, ma'am, if you have sorted your technical issues, are you able to come and present again?
Yeah. Just. My slides are visible. Hello.
Not yet, currently, unfortunately. Hello, ma'am.
Hello.
We can hear you, but we can't see your screens, unfortunately. Not to worry. Unfortunately, ma'am, what we'll do is, Mr. Takana, are you here? If you can hear us, if you can unmute yourself, and we'll try to allow you to present now.
Jay, we can take ma'am's video also, video presentation, if there is some network connectivity issues.
Not to worry, my co-moderator, if you have that video, if you could play it.
Yeah. Please give me some time.
Not to worry.
Mr. Tanaka.
What we'll do in the meantime, while
I'm in meeting you. Kindly go for your presentation.
So what we'll do currently, while they're trying to sort that out, is I've got the. Are you able to see my presentations, guys?
Yes, yes, yes.
So what I've done is I've got the Mr. Francis's question and answers, sir, if you wanted to carry on with those while we sort the technical issues. So this is the first and this is the second photo that Mr. Francis sent us. So on either of this, if you tell me which slide to display, and you can ask your questions and get them answered, sir.
Okay.
Dr. Chaudhry, are you there, sir?
Yeah, yes.
Yes, I've got the. Are you able to see my screen or not, guys? Currently, no.
No, we are
No.
I
not.
can see your
Sorry, guys.
screen.
Okay, perfect. Can you see the screen now?
Yes.
Yeah.
Yes.
Perfect.
Perfect. Sorry, guys. So these are the two images. On either of them, if you ask me to display either one, and we can continue with the Q&A.
I have a question in the chat. I'm trying to send it to you, please, but I cannot send it.
I think the question was asked, what is the algorithm actually?
Yes, that was the question asked to Mr. Francis on his presentation. So if you'd like to unmute yourself, Mr. Francis, if the co-moderator could unmute Mr. Francis and allow him to answer Dr. Chaudhry's questions.
Okay, I'm here now.
Perfect. We can hear you, Francis.
So please, this is the algorithm we proposed based on the text rank algorithm. The difference is that we introduced this parameter here. In the original text rank algorithm, there is no such parameter like this one. So we introduced this one into the algorithm, and that was the major difference. And then over here, we redefined our edge weight for the algorithm, which was fusing the position feature and then the frequency feature to get this edge weight. So the major difference is this parameter here and then this one also. That's it.
Thank you very much for explaining that, Francis.
Oh, okay.
Are the videos ready?
No. Sorry, I'm
Not to
unable
worry,
to
we'll
play
take
that videos.
unfortunately, I've just received a message from Mr. Takana as well. Also,
Yes, and the
sure
another one, Akansha.
bad. So unfortunately, what we'll do is we'll give. Are the videos able to be played? Sorry.
No one forwarded me any kind of documents or videos, so.
Okay. Well, we apologize to Dr. Sharaf and Mr. Takana. However, we will now just move forward with our closing remarks.
Yes, please.
So I sincerely thank all of our authors for their excellent presentations and contributions to this session, and particularly all participants for being part of this international Congress. I hope that the sessions were informative and knowledgeable as well. And for all of the presenters, you will be gaining your digital certificates within 2 working days through the mail. And further, all the papers have already been forwarded to Springer. So the publications will be live to view within the next 4 to 6 months, kindly coordinated and cooperated by the team of ICICT 2021. And I'd also like to give a special thanks to our chair of this session, Dr. Chaudhry, for chairing the session. And as a token of our appreciation, we have created the certificate on behalf of the team of ICICT 2021 and the Global Research Foundation. Thank you for your precious and valuable time and presence, sir. Quickly, before we do end, and we have a little bit of time before our next session, I'd kindly request you all to unblock your videos, share your videos, and we can take a photo to just memorize this day and we can get that on the thing. So once everyone's done, I'll say smile, and then hopefully sometimes it does take a little bit of time to get everyone back, but I'm sure you all look great. And once we have a few more people, we'll get that done.
Actually, sorry, from my side, there is some issue in the video. You can
Okay,
click
not
it.
to worry,
Okay,
sir.
thank you.
Okay, guys, you want to smile, everyone? Perfect, guys. Thank you for being here. We hope you enjoyed the session, and in this time of coronavirus pandemic, we do wish you and your families health and safety, and thank you for coming, and we hope you enjoy any further sessions that you're part of. Thank you very much on behalf of ICICT 2021 and the Global Research Foundation. Thank you, guys.